Hello students, in the previous video we have learned how to find the derivatives of a functions. We have learned how to use the power rule and the chain rule. So in this video we're going to practice applying what we have learned to solve some problem sums. The questions are from exercise 12.1 and 12.2. Right, let's begin by solving some questions from exercise 12.1. Let's do a recap of what power rule is all about. If you're given a function f of x equals to x to the power n, then the derivative f prime of x will be, we bring down the power n, multiply with x, and then the power minus 1. Alright, let's look at question 1. Right, so you're given y equals to 6.5 x to the power 4. Right, so the derivative will be dy over dx. Okay. Right, we're just going to ignore the 6.5, the constants. We're just going to apply the power rule to this. So let's bring down the power 4 times x and then the power minus 1. So 4 minus 1 will give you 3. Alright, so you can easily use a calculator to evaluate 6.5 times 4. Which will give you 26. So this will give you 26x to the power 3. Alright, let's move on to question B. Alright, so remember that the functions, we have to express the functions in the form x to the power of something. So in this case here, you're given a positive index, right? So we have to change it to a negative index. So this will be 4 times 1 over t to the power 5, and that gives you 4t to the power of negative 5. Alright, always simplify the functions that are given first before you do any differentiation. Alright, so we're going to find the derivative of this function s, so that will be s prime. Alright, so we're going to ignore 4, bring the power down, power minus 1. So this is negative 5 minus 1. Be careful, it's negative 5 minus 1 gives you negative 6. Alright, some students will make mistake like give answer as negative 4. Okay, it's negative 5 minus 1, negative 6. So 4 times negative 5 will be negative 20 t to the power negative 6. Change it back to a positive index, that will be negative 20 over t to the power of 6. Alright, let's move on. Let's do part C. So you're given f of x is equals to negative 3 x to the power negative 4. So this is relatively easy. So the derivative will be f prime of x. Alright, ignore the negative 3 first. Bring the power down. Power minus 1. Negative 4 minus 1 is negative 5. So you will get negative 3 times negative 4, 12. Change it to the positive index. That will be 12 over x to the power 5. Okay, let's move on. Alright, this is relatively easy also. Alright, ignore the constant. Alright, bring the power down. Alright, so the power minus 1. So 3/5 minus 1 will give you negative 2/5. Okay, so 0.5 times 3/5 will give you 3 over 10. So this will be 3 over 10 times 1 over u to the power of 3 over 5. We have to change the power to a positive 1. So that will give you 3 over 10 u to the power of 3/5. Alright, so let's move on. Alright, so the derivative for h of x will be h prime x. Okay, that's what we've done for the previous example. Ignore the constant negative 5 over 4. Alright, we just differentiate this. Bring the power down, which is negative 1/5. And then the power minus 1. So it's negative 1/5 minus 1. So that gives you negative 6 over 5. Alright, and then you can use a calculator to evaluate the coefficients. So that will give you 1/4. So this is 1/4 times 1 over x to the power of 6 over 5. Multiply the numerator, multiply the denominator, and this is what you'll get. Alright, that's question 1. Right, let's look at question 7. So for question 7, we're asked to find the gradient of each curve at a certain point. Let's look at part A. So part A, you're given the functions y equals to 5x to the power of 2 minus 4x plus 2. Alright, so before we can find the gradients of any point, let's find the derivatives, which is your dy over dx. So that will give you, ignore the 5, differentiate x squared. So bring the 2 down, 5 times 2 is 10, right? And then the power minus 1, so 2 minus 1 gives you 1. Differentiate negative 4x gives you negative 4. Differentiate constant gives you 0. Alright, that will give you 10x minus 4. So we're going to substitute x equals to 1. So gradient at x equals to 1 is 10 times 1 minus 4 gives you 6. Alright, so relatively manageable. Let's go on to do part B. Right, so for part B, before we apply the concepts of differentiation, let's do some simplification. Alright, so convert your square root x to x to the power half. Let's open up the bracket, so you get 3x to the power half. X to the power half times x. X means x to the power 1. Same base, you add the power half plus 1 will give you 3 over 2. Alright, so let's find the derivative, which is your dy over dx. Okay, so we ignore the 3, bring the power down half. So 3 times half is 3 over 2. Half minus 1 is negative half. Alright, bring 3 over 2 times negative 2, that will give you negative 3. Then 3 over 2 minus 1 will give you half. Alright, so we're going to substitute x equal to 4. So gradient and you can just easily use a calculator to help you evaluate the answer. Right, so that gives you negative 21 over 4. Alright, let's move on to part C. Alright, so for part C, likewise, let's simplify the expression first. So we're going to open up the brackets. So that will give us 2x squared minus 2x plus 3x minus 3 over x. Simplify further will give you 2x squared plus x minus 3 over x. Alright, we're going to separate it into individual fractions, so it will be 2x squared divided by x plus x divided by x minus 3 over x. So that will give us 2x plus 1 minus 3x to the power negative 1. Alright, so we are all ready to do your derivative, which is dy over dx. Differentiate 2x, you get 2. Differentiate 1 constant, you get 0. The next step is ignore your negative 3, bring the negative 1 down. So it's negative 3 times negative 1 gives you positive 3. And then power is negative 1 minus 1 gives you negative 2. Alright, so therefore the gradient at x equals to negative 2 is 2 plus 3 bracket negative 2 power negative 2. And again, you can just easily use a calculator to help you evaluate the answer. Right, and that gives you 11 over 4. Right, so we have done simple applications, and then we proceed on to find gradients of the curve at certain point. So for question 9, you will see that it's slightly different. Okay, it's not so straightforward by finding gradient of at a certain point. In this case here, you're given the gradient, and then you ask to find at which point. Alright, at which point of the curve that will gives you the gradient negative 7 over 2. Right, so if you have a graphing apps with you, and then if you key in this function y equals to 10 over x minus x, you'll see that the curve is, I think, something like this. Right, so what we're saying is that there are 2 points there because of the word point, so I suspect there are 2 points there. Alright, so we don't know which point. So supposing the point is here, and then we can draw a gradient line. So what we're saying is that the tangent of that gradient line is equals to negative 7 over 2. Alright, so basically this is what the questions it's talking about, right? But the basic concept is still we need to simplify the function, express it at 10x to the power negative 1, and then find the derivative, which is negative 10x to the power minus 2. Differentiate x, you get 1, so negative 1, and then let's convert it to positive index. All right, so what we are saying that this derivative, we're going to equate it to negative 7 over 2. So negative 10 over x squared minus 1 is equals to negative 7 over 2. So negative 10 over x squared will be negative 7 over 2 plus 1. That gives you negative 5 over 2. All right, can multiply negative on both sides. That will give you positive, right? And then do a cross multiply. That will give you 5x squared equals to 20. X squared is 4. Right, so x can be positive 2 or negative 2. Right, so we're saying that there's a point here where x is 2. There's another point here, x is negative 2. And then this, of course, my diagram is not drawn to scale. These two tangent supposed to be parallel to each other because they're supposed to have the same gradient, negative 7 over 2. Alright, so the two lines are supposed to be parallel. So let me say again that my diagram is not drawn to scale. Alright, so we're supposed to find the coordinates of the point, which means I need to find the x coordinate, also the y coordinate. So I need to substitute x equals to 2 into the equations of the curve to find the y coordinates. So when x is equals to 2, y will be 10 divided by 2 minus 2, and that gives you 3. And when x is equals to negative 2, y will be 10 divided by negative 2. Negative times negative become positive 2, so that will give you negative 5, yeah, negative 3. Alright, you're not supposed to give your answer in this form because you're asked to find the coordinates of the point, so you need to leave your answer as point form. Point form means leave it as a coordinate form like x, comma, y. So therefore, the points are 2, 3 and negative 2, negative 3. Alright, so that's how you do question 9. Alright, let's look at question 10. Basically, question 10 is the same as almost the same kind of context as question 9, except that you must understand what you need to equate your gradient functions or your derivative to. Previous question 9, you're told that the gradient is negative 7 over 2. Here, you need to understand what it means by when the curve is least steep. Right, so when you say the curve is least steep, we are referring to the minimum point. So the minimum point, it's supposing the curve is like that. So supposing this is a minimum point, if you draw a tangent line, then you see that that tangent line is actually a horizontal line. And the horizontal line would have gradient equals to 0. Alright, so you need to know this concept. Otherwise, you wouldn't know what to equate your dy dx equals to. Okay, so that's fine. Let's find the gradient function first, which is your dy over dx. So differentiate 2x squared, you will have 4x. Differentiate negative 3x, you get negative 3. Differentiate 7 is 0. Okay, so we're going to equate, let dy over dx equals to 0, which means we let 4x minus 3 equals to 0. So x will be 3/4. Okay, we asked to find the coordinates of the point. So when x is equals to 3/4, we're going to substitute that into our equations. And just use a calculator to help you evaluate. Right, and you'll get 5, 7 over 8. Right, so therefore, the point is 3/4, 5, 7 over 8. Alright, so the concept here is knowing that the gradient at the point where the curve is least steep is when your dy dx equals to 0. Okay, let's move on to solving some questions from exercise 12.2. Alright, so for question 3, we are asked to use the chain rule. Okay, so what is chain rule? So I'm just going to show you the shortcuts to using chain rule, just the shortcuts only. Supposing we asked to differentiate x plus, okay, wait, just make it a generic form, okay? Supposing you asked to differentiate bracket ax plus b to the power n. Alright, so the chain rule works this way. Okay, ignore whatever that's inside the bracket, just concentrate on the power first. So the power n is the same thing as what you apply using the power rule. Just concentrate on the power first, then the power minus 1, except that there's one extra step. What is the extra step? Because if you were to zero into the variable in your bracket, you will see that you can differentiate it further. Alright, so you need to differentiate the one inside the bracket, which will give you, differentiate ax will give you a, differentiate b is a constant, so you will just get 0. So that will give you a times n bracket ax plus b to the power n minus 1. Right, so that is chain rule. Okay, it's not difficult. So let's look at part A. Alright, so we're going to differentiate. Okay, you see that in part A, you're not given a name for a function. In the earlier questions, you're given a y equals to blah, 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 or f of x equals to blah, 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 or s equals to blah, blah, blah. Here, you're not given a name. Right, so how do you write your derivative? Yes, you write it as d over dx, and you're differentiating this one. You're differentiating this function. Okay, so you present your answer in this way. Alright, so let's start off by focusing on the power, which is 6. Bring it down to the front. The power minus 1, which is 5, times you differentiate whatever that's inside the bracket. Alright, so you differentiate x squared, you get 2x. Differentiate 5x, you get 5. And then you can just put 2x plus 5 to the front so that you can rearrange it properly. Alright, okay, let's move on. Let's look at part B. Alright, so let's simplify. Okay, you see that this one here is 1 over x to the power of 5. So we need to convert it into negative index. So that will give us x to the power of negative 5. Okay. Alright, so here we can actually, hang on. If this is the case, we don't need chain rule here, what? Maybe there's something wrong with the question. Okay, so that it's some error. Right, we'll see that there should be a bracket here. Okay, it makes sense then, because if the earlier example that I show you doesn't make sense, you don't really need to use the chain rule. Here it makes sense to use the chain rule. Alright, so we're going to differentiate. So we're going to express 1 over x as negative index. Alright, so let's focus on the power, bring the 5 down. Power minus 1, that is 4, times differentiate whatever that's inside the bracket. Alright, so x to the power of negative 1, change it back to 1 over x. We only change it to negative index when we need to apply the differentiation. Okay, otherwise, in your final answer, you should just convert all the negative index into positive 1. So differentiate x cubed, we get 3x squared. Differentiate x to the power negative 1. So negative 1 bring down to the front will be negative 1 times negative 1 become positive 1. And then x to the power minus 2. Okay, let's rearrange it. Okay, I hope you can understand this part here. It just take -1 times -1 gives you +1. Right, and then the -1 minus 1 gives you -2. Okay, so this is how you do part B. Right, let's move on to part C. Okay, so what we're going to do is we're just going to ignore half first, and we're just going to separate them into two fractions, so that I'm going to convert this, okay, into a negative index, so that give us to the power of -6. All right, so what we do is ignore half is constant, we just ignore it, and then bring your power -6 to the front. Power -1, so -6 minus 1 will give you -7 times differentiate the one inside the bracket, which is x to the power of 3 minus 1 to the power of -6. Alright, so half times -6 will be -3. So differentiate x cubed, you'll get 3x squared. And differentiate -1, you get 0. Alright, so we can take -3 times 3x squared, which gives you -9x squared. And we're going to convert this into a positive index. So that will give us -9x squared over bracket x to the power of 3 minus 1 to the power of 7. Alright, let's proceed on to part D. So I would have to erase this part here to make space to do part D. Alright, so let's look at part D. So we need to find the derivative of this function. Alright, so step number 1, bring the power down. Step number 2, power -1, that gives you 4. Step number 3, differentiate whatever that's inside the bracket, which is x to the power of 4 plus 5x minus pi. So differentiate x to the power of 4 will be 4x cubed. Differentiate positive 5x will get plus 5. Pi is a constant. Pi is 3.142, blah, blah, blah is a constant. Differentiate constant, you get 0. Okay, so bring your 4x cubed to the front. Okay, basically that's the answer for part D. Alright, so for question 5, we're supposed to find the gradients of the curve at a certain point. So you see that this question is similar to one of the questions we've done in 12, I think question 9 in 12.1, except that now the functions given to you, it's more complicated. You need to apply the chain rule. The power rule does not work anymore, right? But the concept, the way to do it is still the same. All right, what do I mean by still the same? And still the same means you still have to find your derivative. Okay, find the derivative. All right, so you're given, let's look at part A first. Given y equals to bracket 3x minus 2 to the power of 3. Alright, so that's find your derivative. Okay, bring the power down. Power -1, so 3 minus 1 is 2 times differentiate whatever is inside your bracket. Differentiate 3x, you get 3. Differentiate -2, you get 0. So that will gives you 9 bracket 3x minus 2 to the power of 2. So that is your gradient function. So at x equals to 2, the gradient will be 9 bracket 3 times 2 minus 2 to the power of 2. So you can just use a calculator to help you evaluate that. Right, and you will get 144. Okay, let's move on to part B. Okay, so let's convert square root to 7 minus 3x to the power half. Let's find the derivative. Bring the power down. Power minus 1. So half minus 1 is negative half. Times differentiate whatever that's inside your bracket. So that gives you half times 7 minus 3x to the power negative half. Differentiate 7, you get 0. Differentiate negative 3x, you get negative 3. So that gives you negative 3 over 2, 7 minus 3x to the power negative half. So we're going to substitute x equals to 1. At x equals to 1, the gradient will be negative 3 over 2, 7 minus 3 times 1 gives you 3, the power negative half. So basically just use a calculator to help you get the answer. Right, so that gives you negative 3/4. Okay, so that's part B. Let's look at part C. Alright, likewise convert this into a negative index, so that will be bracket 3x minus 2 to the power negative 1. Okay, so that's find your derivative. Okay, bring your negative 1 to the front so that become negative in front. Negative at the coefficients, and then 3x minus 2, negative 1 minus 1, negative 2 times differentiate whatever is inside your bracket. Differentiate 3x, you get 3. Differentiate negative 2, you get 0. So that gives you negative 3 bracket 3x minus 2 to the power negative 2. So at okay, in this case here, you're given y equals to 1. So what we need to do is we will have to equate your curve equals to 1 to find the x coordinate. Because you can't substitute y equals to 1 into your dy dx. You need the x coordinate. Right, so we need one extra steps here. So when y is equals to 1, 1 over 3x minus 2 is equals to 1. If you do a cross multiply, you get 3x minus 2 equals to 1. So x will be equals to 2/3. Wait, hang on. Wrong. X is equals to 1. Negative 1 plus 2, yeah. X is equals to 1. So this is what we're going to substitute. So at x equals to 1, the gradient is negative 3 bracket 3 times 1 is 3 minus 2 to the power negative 2. Right, so if you use a calculator, that will gives you negative 3. Right, let's move on to part D. Right, if you look at part D again, you're given only the y coordinate and not the x coordinate. So we will have to substitute y equals to 1 over 8 to find the y coordinate, or to find the x coordinate. Right, so we need to equate 1 over bracket 2x minus 5 to the power of 3 equals to 1 over 8. So if you do a cross multiply, what we are saying is bracket 2x minus 5 to the power of 3 is equals to 8. So we need to cube root 8. Alright, cube root 8 will give you 2. And then from there you will find 2x is equals to 7, x is equals to 3.5. Right, so we need to use that value to substitute into our dy dx for part D. Okay, and I find that I'm running out of space. Oops, wrong. Okay. Right, so our gradient function will be, okay, we need to convert that into your negative form. So that will gives you y equals to bracket 2x minus 5 to the power negative 3. Okay, so bring the negative 3 to the front. Negative 3 minus 1 gives you negative 4 times. Differentiate whatever is inside the bracket, which is your 2x minus 5. So differentiate 2x, you get 2. Differentiate negative 5, you get 0. So that will give you negative 6 bracket 2x minus 5 to the power negative 4. So at x equals to 3.5. So the gradient will be, right, basically you just substitute into negative 6 bracket 2x minus 5 to the power negative 4, and then use your calculator to have you evaluate, and you should get negative 3 over 8. Okay, I'm so sorry, I apologize for the messiness of the presentation. Alright, so if you look at question 8, it's linked to the earlier chapter we have learned, the partial fractions. Right, but in this case here, they're rather kind, right? As in they actually gave you the partial fractions in the questions. Right, so all you need to do is just to find the value for the unknown a and b. Okay, so how do we do it? So we're just going to combine this into one fraction. If you were to recall how we do that in partial fractions. So your 2x minus 1, I think I will need more space. So I think I will just do it here instead. So 2x minus 1 over bracket x minus 1 squared. Okay, we're going to combine this into one fraction. So the denominator would be bracket x minus 1 to the power of 2. So I need to multiply this with x minus 1. So that will be a times x minus 1 and b times 1. Because my denominator is already x minus 1 to the power of 2. Okay, so I'm just going to compare the numerator. So 2x minus 1, because the denominator is already in the same form. Can you see that the denominator is already in the same form? So you just need to compare the numerator. And we can just use substitution. Alright. Oh, okay, don't need substitution. I think, yeah, substitution easier. Sorry, keep changing my mind. So we can just let x equals to 1. Because if you let x equals to 1, then you can find b first, eliminate a. So when x is equals to 1, 2 minus 1 gives you 1. So your a is gone because 1 minus 1 is 0. 0 times a is 0, right? This will be, a will be gone. So therefore your b is equals to 1. Okay, and then you just let x equals to 0 to find values of a. So 2 times 0 minus 1 will give you negative 1. 0 minus 1 will be minus 1. B will really find it to be 1. So that will be negative a plus 1 gives you negative 1. So a will be negative 1 minus 1 negative. A will be 2, right? Okay, so we have found the values of a and b. Right, so for part 2, what do we do? Yes, we're just going to substitute into partial fraction. So this is equals to our 2 over bracket x minus 1 plus 1 over bracket x minus 1 to the power of 2. Okay, we're going to convert that into a negative index. So that is to the power negative 1 plus this is to the power negative 2. Alright, this one actually need you to be good at your rules of your indices. So I actually have a video on that. I'll put the link in this video so that you can recap on the concepts that is needed, okay, to do your differentiation correctly. Alright, so we are finding the derivative of these fractions, which means we are finding the derivative of our partial fractions. Okay, right, so this one here, let's look at the power negative 1 bring to the front will be negative 2. Negative 1 times 2 is negative 2, right? And then minus 1, the power minus 1, so that gives you negative 2 times differentiate inside this here. Differentiate x is 1, differentiate negative 1, it's 0. Let's move on to the next one. Bring the negative 2 to the front. Negative 2 minus 1 is negative 3 times differentiate x minus 1. Differentiate x, you get 1. Differentiate negative 1, you get 0. Okay, let's simplify further. We can just convert it into positive index already. So that gives you negative 2 over bracket x minus 1 to the power of 2. Plus times minus is minus, so minus 2 over bracket x minus 1 to the power of 3. That's how we do it. Right, let's look at the last questions. So the last questions is similar to the questions we have done, the last two questions we have done from exercise 12.1, except that the curve, the functions you're given, is slightly more complicated, so you have to apply chain rule, right? But the methods of solving it is the same, right? So let's find your derivative first. Let's simplify, convert your functions to radical. You're giving radical form, so let's change into index form. So square root means the power half. So let's find dy over dx. Alright, bring the half down. Half minus 1 is negative half times differentiate whatever that's inside the bracket. Alright, so you differentiate x squared, you get 2x. Differentiate negative 4, so you get negative 4. Differentiate 1, you get 0. Okay, let's simplify further. So you see that the half we can actually multiply with your bracket 2x minus 4. That will give us half times 2x will give you x. Half times 4 will give you 2. Right, and then we're going to change this into a positive index. So that will give us x minus 2 over, then change it back into radical form. Alright, so that is our derivative, and then we're going to equate it to 2. Okay, we're going to do a cross multiply. Alright, and we're going to do a x minus 2 times 1, which is basically be x minus 2. Right, so we're going to square both sides. Square both sides, we'll get rid of the square root. But be careful when you square an equation, right? You will be introducing some values that is erroneous. Okay, when you square something, you'll be introducing some values that may not fit into your original functions, which is your dy dx. Okay, so let's try to square it first. So you have square of 2, you get 4. Square the square root. Okay, wait. So we're just going to square both sides. So square 2, you get 4. Square the square root is gone. Okay, and then this one you can apply your a minus b, your identity, to get a squared minus 2ab plus b squared. So that will give us 4x squared minus 16x plus 4 equals to x squared minus 4x plus 4. Bring everything to the left hand side, you will get 3x squared minus 12x. 4 minus 4 is 0. Alright, so take out your common factor 3x. So we're saying 3x is equals to 0, or x minus 4 equals to 0. So x is equals to 0, or x is equals to 4. Right. Okay, one of them is rejected. Alright. That earlier on I mentioned that when you square something, right? When you square something, you'll be introducing some erroneous answer. Right. So when x is equals to 0, you're going to substitute into this original one, the original equations before you square it. You will see that you will get let's use a different color to show you. So when x is equals to 0, 0 minus 2 over square root 1 will gives you negative 2 over 1. But on your right hand side is 2. So negative 2 does not equate to 2, right? So therefore this one is rejected. How about the other one, value when x is 4? Let's see what happens when x is 4. So when x is 4, then 4 minus 2 over square root 16 minus 16 plus 1. And that's alright. That's alright because that will give you 2. Okay, which is what we have on the right hand side too. So therefore x equals to 4, it's alright. But x equals to 0, it's not alright. Because what you get is negative 2, which does not equate to your 2 here. Okay, right. So when x is equals to 4, you have to substitute back into your curve to get your y coordinate, which is 16 minus 16 plus 1 gives you 1. So therefore, the point that is required will be 4, 1. Alright, so that's all for this video. Happy learning.